Good morning, children. Today, I would like to fondly remember our late President, Dr. APJ Abdul Kalam sir, who was a great inspiration to both teachers and students. Let me share with you the two quotes. The most important part of education is to imbibe among the students the spirit of we can do it. The second one, for the teachers, a teacher has to create a lifelong autonomous learner. Dear children, it is your response or your phase of great satisfaction which is giving all teachers a great strength to continue with our noble work. The next topic in class 9 is Rationalize the Denominator. Before starting the topic, let us revise some useful facts which is usually needed for the topics ahead. In comparison with a plus b whole square is equal to a square plus 2ab plus b square, a minus b whole square is equal to a square minus 2ab plus b square, and a plus b into a minus b. With the radical symbols a and b, how the identities are taking a change. Number 1, square root a plus square root b the whole square is the same as square root a the whole square will take the value a. 2 into square root into b is taking the value of 2 square root ab plus square root b the whole square is the same as b. The second identity, root a minus root b the whole square is the same as a minus 2 root ab plus b. All the terms remains the same, only the value for the root ab term will be negative. The third identity, square root a plus square root b into square root a minus square root b is the same as a plus b into a minus b is a square minus b square. If you go in the same way, it is square root a the whole square minus square root b the whole square is the same as a minus b. These expansions you have already done in your previous exercises, just for a review. Number 4, square root a into square root a is the same as a. Square root a into square root b is the same as square root of ab. Square root a divided by square root b is the same as square root of a by b. In the next session, when any of these applications are there, you can copy this in your notebook before starting listening to the next topic. The first topic is type 1, how to rationalize the denominator of questions like 1 by square root 2. You can see the denominator is an irrational number, square root 2. The question is, convert that square root 2 into a rational number. With what number or with what irrational number we should multiply root 2 so that it takes the value 2 is by the property of root a into root a is equal to a. Thus, if this denominator of root 2 has to become 2, the denominator should be multiplied with root 2. At the same time, the numerator also should be multiplied by root 2. Thus, the method of changing the questions like 1 by root 2 into a denominator with rational denominator, multiply and divide with the same irrational number. That is root 2 by root 2. 1 into root 2 is root 2 or root 2 into root 2 is the same as 2. Thus, the denominator has become a rational number. Let me take a second example in this type. You have to rationalize 2 by square root 5. The denominator is an irrational number. You have to convert into a rational number, a same procedure. Multiply and divide by the irrational factor root 5. 2 into root 5 is giving you 2 root 5, and root 5 into root 5 is giving you 5, which shows that the denominator is rationalized. The third pattern, if you are given a number like root 2 plus root 3 divided by root 5. Root 2 plus root 3 divided by root 5. That means the denominator has to be rationalized. Method remains the same. The only thing, both the numbers should be multiplied and divided by square root 5. Expand using distributive law. Root 2 into root 5 is the same as square root 10. Root 3 into root 5 is the same as root 15 divided by root 5 into root 5 is equal to 5. Root 10 as well as root 15 are of different irrational factors. Thus, the answer remains as root 10 plus root 15 by 5. Thus, to rationalize a denominator which is having only one irrational factor, multiply and divide the given number with the same irrational factor, and thus the denominator will be rationalized. After learning the rationalization of denominator with only one term, let us proceed with numbers with two terms in the denominator. The question is, rationalize 1 by root 3 plus root 2. You can see here both the numbers are irrational factors and they are separated with the addition symbol. If you want to rationalize this denominator, the identity used will be square root of a plus square root b into square root a minus square root b, then only the numbers are a minus b. In that case, what will be the factors you will be multiplying with numerator and denominator is the unlike sign of the sign which is given in the denominator. That is 1 by square root 3 plus square root 2 has to be multiplied and divided by the term which is having an opposite sign which is given in the denominator. Root 3 minus root 2 is called as the word conjugate. In short, we used to say multiply and divide by the conjugate of the denominator. The conjugate of root 3 plus root 2 is root 3 minus root 2. The opposite sign will give you the conjugate value. 1 into root 3 minus root 2 is the same as root 3 minus root 2. It takes the identity of a plus b into a minus b, and it is root 3 the whole square minus root 2 the whole square. The final answer is root 3 minus root 2 by root 3 the whole square is 3 minus root 2 the whole square is 2, and the final answer is root 3 minus root 2 by 1 or root 3 minus root 2. The second example, 1 by square root 7 minus square root 6. The conjugate of root square root 7 minus root 6 is root 7 plus root 6 by root 7 plus root 6. When you are multiplying and dividing by the conjugate, root 7 plus root 6. 1 into root 7 plus root 6 is root 7 plus root 6 by same procedure, root 7 the whole square minus root 6 the whole square, root 7 plus root 6 by root 7 the whole square is 7 minus root 6 the whole square is 6, or the answer is root 7 by plus root 6. Root 7 plus root 6. What happens when the examples like 2 root 3 by root 5 plus root 3? The procedure is the same, only the numerator has to be multiplied with the conjugate. Instead of the numerator 1, it is taking different values. Into conjugate is root 5 minus root 3 by root 5 minus root 3. 2 is a whole number. Root 3 into root 5 is root 15. It is 2 square root 15. 2 into 1, 2. Root 3 into root 3 is 3. It has become with the sign minus 2 into 3 by square root 5 the whole square minus square root 3 the whole square. It is 2 square root 15 minus 2 into 3 is taking the value 6 by root 5 the whole square is 5 minus root 3 the whole square is 3. Again 2 square root 15 minus 6 by 2. After reaching this step in mathematics, normally we leave any answer in a simplified form. Thus, 2 root 15 minus 6 by 2 is not a simplified answer. The simplified answer can be, after this step, for 2 and 6, the common number available is 2 square root 15 minus 6 divided by 2 is 3 divided by 2. You can cancel the same or you can simplify it, and so the final answer is root 15 minus 3. Please go ahead with these problems, as you cannot find such problems in the textbook. The matter is the same. How to simplify is take a common factor outside so that it will get cancelled with the denominator and thus the answer will be in the simplified form. A third example, 2 by square root 2 plus square root 3. Rationalize the denominator of 2 by square root 2 plus square root 3. You will understand that the denominator is having two terms, and you will rationalize the denominator by multiplying and dividing by the conjugate into root 2 minus root 3 by root 2 minus root 3. 2 into root 2 is giving you 2 square root 2 minus 2 into root 3 is giving you 2 square root 3 by root 2 the whole square minus root 3 the whole square. The procedure is 2 square root 2 minus 2 square root 3 by square root 2 the whole square is 2 minus square root 3 the whole square is 3. The answer is square root 2 minus square root 3 by, what is the value of 2 minus 3? The value of 2 minus 3 is negative 1. That is, the answer is 2 square root 2 minus 2 square root 3 by minus 1. As I told you earlier, any answer should be in the most simplified form, or it should be in the standard form. When the denominator is a negative, we cannot say it is in the standard form. Thus, the same answer has to be expressed in the standard form as when the denominator takes a negative value to make it positive. The concept is you are multiplying both numerator and denominator by a -1, but easily what you can do is change the sign of as many numbers on the numerator. Here the numerator 2 root 2 is having a positive sign. It will take a negative sign. -2 root 3 will take a positive 2 root 3, and thus the denominator has become a positive 1. The concept is you are multiplying and dividing by -1, but whenever you get a denominator -1, change type 3 1 by root 5 plus root 6 plus root 11. All the three terms in the denominator you can see here 1 by with a radical sign. Rationalize the denominator of 1 by root 5 plus root 6 plus root 11. Your topic under consideration mostly relates with, you can see the total of 5 plus 6 is 11, or the questions like 7 plus 6, 13, etc. So, try to understand these problems in the first stage. Here also, the concept is multiply and divide with the conjugate, but which two terms you will connect together and leave the third term for applying a conjugate is, first two terms you consider as a single term, root 5 plus root 6 as a single term and root 11 as the second term. So what is the conjugate of root 5 plus root 6 plus root 11? It will be only the unlike sign of plus root 11 as minus root 11. So the conjugate is root 5 plus root 6, no change for that, minus root 11 by root 5 plus root 6 minus root 11. The conjugate of root 5 plus root 6 plus root 11 is the sign only of the third term. The next concept is the numerator multiplies as root 5 plus root 6 minus root 11 divided by, as I told you, this you are taking as a single term, a square minus b square. So it takes the form of root 5 plus root 6 whole square as the first term minus root 11 the whole square. That is, both the terms are clubbed together as the first term. Numerator remains the same, root 5 plus root 6 minus root 11 by. Here, two identities. What is root a plus root b the whole square is root a the whole square plus 2 root ab plus root b the whole square, which shows that root 5 the whole square, which gives you root 5 the whole square plus 2 into root 5 into root 6 plus root 6 the whole square, which shows the expansion of root 5 plus root 6 the whole square minus root 11 the whole square is simply 11. Numerator no change, root 5 plus root 6 minus root 11 by root 5 the whole square is 5 plus 2 root 30 plus root 6 the whole square is 6 minus 11. When you reach this stage, you will understand 5 plus 6 is 11 and this 11 is getting cancelled. That is why I told you, you will get numbers of the type 5, 6 and the total is 11. Thus, the answer will be now root 5 plus root 6 minus root 11 by 5 plus 6, 11. Plus 2 root 30 minus 11. 11 and 11 gets cancelled. Again, is the denominator rationalized? No. It is again 2 root 30. That means you have to rationalize again. Again, multiplying with root 30 by root 30. There is no need of multiplying with 2 because already 2 is a rational number. Even if you do with root 30 by root 30, the denominator becomes a rational number. Root 5 into root 30 is root 150 plus root 6 into root 30 is root 180 minus root 11 into 30 is root 330 by root 30 into root 30 is 30. 2 into 30 is equal to 60. Thus, the denominator is rationalized. But how to simplify this answer? How to simplify this answer? The radical symbol here, square root, when you observe square root 2, the meaning is the index is 2, or it's already understood that it is square root of a number. Same way, square root 150 is the same as telling you that the index is 2. How can you write that square root 150 in the simplified form is, listen to the explanation. 150 is divisible with the prime number 2. It is 75. 75 is divisible with the prime number 5. It is 15. 15 is divisible with the prime number 5. It is 3. Again with 3 and 1. How to write root 50 in the simplest form is, as I told you, even if the number is missing, the number present is 2. Thus, 5 is the number factor which has 2 factors there. That 5 will be taken out. The remaining 2 into 3, since they have only 1 factors, they will be multiplied and arranged as root 6. Similarly, 180. How to proceed with 180? Factorize 180 with the prime numbers. By 2, 90. By 2, 45. By 3, 15. By 3 again, 5, 5, 1. With the same explanation, you can see the factors. 2 is occurring twice. 3 is occurring twice. 5 is occurring only once. You can leave it. Thus, 2 into 3 is 6. It will be simplified as 6, the remaining factor inside the square root. Let us check whether we can do 330 in a similar way. 330 will be factorized as with 5, 6 5s are 30 and 66, with 2, 33, with 3, 11, with 11, 1, which shows that the factors 5, 2, 3, 11 all are occurring only once. Thus, it cannot be simplified, or it will remain as square root 330 by 60. This will be the final simplified form. One more example with the denominator having 3 terms will help you to understand it very well. Rationalize 1 by root 7 plus root 6 minus root 13. The first step is 1 by root 7 plus root 6 will be grouped as a single term minus root 13. The conjugate of this term will be root 7 plus root 6. Instead of minus 13, the conjugate is plus root 13 by root 7 plus root 6 plus root 13. Make sure that this symbol will not be changing because we are considering root 7 plus root 6 as a single term. Numerator, root 7 plus root 6 plus root 13 by the identity of a plus a minus b. A plus b is a square minus b square, which gives you root 7 plus root 6 the whole square minus root 13 the whole square. Numerator remains the same, root 7 plus root 6 plus root 13 by root 7 the whole square plus 2 into root 7 into root 6 plus root 6 the whole square minus root 13 the whole square is the same as 13. Root 7 plus root 6 plus root 13 by root 7 the whole square is 7 plus 2 root 42 plus 6, 7 6s are 42 plus 6 minus 13. As I explained, 7 plus 6 is 13 and this 13 is getting cancelled with minus 13. Thus the next step is root 7 plus root 6 plus root 13 divided by 2 square root 42. Now rationalize the denominator with square root 42 by square root 42. Root 7 into root 42 is the same as square root of 294 plus root 6 into root 42 is the same as square root 252 plus square root 13 into square root 42 is the same as 3 2s are 6, 2 4 3s are 12. Same as 546 by square root 42 into square root 42 is simply 42. 2 into 42 is 84. How to simplify root 294, root 252 and root 546? Square root of 294. Square root 294, it is divisible with 2. 2 1s are 2, 9 by 2, 4 2s are 8 and 47. How to check which number is divisible? With the help of divisibility test. 7 plus 4, 11 plus 1, 12. It is divisible with 3. 3. 4 3s are 12, 27 or 9 3s are 27. Thus 7, 7, 1. You can see the factor 7 is repeated twice. You can write it as 7 square root 6 plus square root 252. 252 is factorized with 2, 126 by 2 is 63 by 3 is 21 by 3, 7, 7, 1. The factors 2 and 3 occurring in pairs thus can be multiplied as 2 into 3, 6 root 7 plus square root 546 can be found out as 546 by 2. 2 2s are 4, 2 7s are 14, 273. The same rule of divisibility for 3, 7 plus 3, 10 plus 2, 12. It is divisible with 3, it's going as 91. 91 is divisible with 7. It will take 7 1s are 7 and it is 13 and all are prime numbers which is occurring only once. Thus, 546 will remain as such by 84. So, the final answer is 7 root 6 plus 6 root 7 plus square root 546 by 84. Please try to do the exercise questions with the denominator as a single term and the denominator with 2 terms only. The denominator 3 terms we will work out later once again.